Thank you. Thank you very much. I'm glad to be here. I just give you a little bit of background before I start. Um, uh, my name is Raj Batlow. I have been with the company 26 years. This is the only company I worked for, Milliken. I started with Milliken in the chemicals business. In fact, I used to run I started in the R&D group. And then I moved to Singapore in 2005, so about 11 years back. And now I run the FR business, flame retardant business, for the company in Asia Pacific. Right? So I'm going to give this presentation. Hopefully, it's going to be from a fabric producer's point of view. Hopefully, it's going to be educational as well for you. We'll see how it goes, right? All right. So this picture right here is a picture of our headquarters. This is in Spartanburg, South Carolina, which is eastern coast of the U.S. So Milliken Company is the parent company. Westex is the business, is the brand under which we sell flame-resistant fabrics, right? So when you look at flame-resistant fabrics or flame-resistant PPE, the technology is all in the fabric itself, right? So we sell the FR fabrics under the brand Westex. Now, in terms of the history of our how long we've been in the FR business, it's been a long time. We started doing this business. Milliken started this business supplying to the U.S. Army since the Second World War, right? So we've been in this FR business for that long. But we had always been in supplying to the defense, so we had never been in the commercial area. And in a few years back, our board and our senior management decided that this was a good business for us to be in, because it, in the end, is good for human beings, right? It saves people's lives. So we decided that we were going to start a commercial side of the business, and we acquired a company called Westex in 2014. That Westex was based out of Chicago. And then in 2015, we acquired a company called Springfield. This company was based out of North Carolina. And so with that, with the acquisition of those two companies and our own internal technologies, Milliken is probably the only company under the Westex brand that has the full suite of FR technologies for fabrics, in the only company that has that. Okay. So this next picture, in fact, the next two slides, what happens is, even though you take all the precautions you can, and you have all of the processes in place, and yet accidents happen, right? This is just 2016, some of the pictures that I'm showing you, accidents that have happened just this year, in spite of all of the precautions that are taken. And when accidents happen, it affects people, right? The impact is on people. And that is what this business is about. This business is about making sure that does not happen, right? This business is making sure it is about performance and it's about protection, right? Okay, so with that, let me go into first talking about what exactly is a burn, right? So you have first, second, and third degree burns. The first degree burn is where you get redness on your skin. It's not permanent. Second degree burn is where you would have blistering, but the skin does regenerate. And the third degree burn is where your total skin is destroyed. This is where you require grafting, so the skin does not regenerate. Okay. Let me play this video for you. So this is kind of the first video. I'm going to play two videos for you right now. The first video basically shows you, this is somebody who's wearing a non-FR, so regular clothes, right? Wearing regular clothes and working on an electrical equipment.
This mannequin is wearing polyester cotton shirt and pants, targeting category 2 here. A large arc and an immediate fire. And notice that the back of the garment is on fire immediately, even though the arc never hit him in the back. Stop, drop, and roll is not going to put this out. This fire is too aggressive for that. The pants are on fire as well. It's hard to see right now, but when our firefighter moves the mannequin, you can clearly see that the pants are ignited as well. And the shirt
It is connected,
almost completely burned off.
but I don't hear it.
Here you have a split screen, slow motion view at 3,000 frames a second. You get a terrific look at the arc. Comes out, hits the mannequin, and bounces to his right and left and down, but never gets his back. And in a moment here, as the arc starts to subside, you'll see the garment on fire as the smoke clears and starts to rise. It's an outstanding look as pieces of burning and melting polyester cotton are being thrown away from the mannequin on fire, and the smoke is lifting from the knees on up, and you can clearly see the garment on fire. This sort of incident is going to result in catastrophic or fatal body injury. Catastrophic and fatal injuries can be prevented by wearing the appropriate PPE, including flame-resistant fabrics.
Yes, I connected it, but it's not playing it. Would you hear that? Was that any? No? No? Oh, okay.
This mannequin is wearing polyester cotton shirt and pants, targeting category 2 here. We have a large arc and an immediate fire. And notice that the back of the garment is on fire immediately, even though the arc never hit him in the back. Stop, drop, and roll is not going to put this out. This fire is too aggressive for that. The pants are on fire as well. It's hard to see right now, but when our firefighter moves the mannequin, you can clearly see that the pants have ignited as well, and the shirt within seconds is almost completely burned off the mannequin. Here you have a split screen, slow motion view at 3,000 frames a second. You get a terrific look at the arc. Comes out, hits the mannequin, and bounces to his right and left and down, but never gets his back. And in a moment here, as the arc starts to subside, you'll see the garment on fire as the smoke clears and starts to rise. It's an outstanding look as pieces of burning and melting polyester cotton are being thrown away from the mannequin on fire, and the smoke's lifting from his knees on up, and you can clearly see the garment on fire. This sort of an incident is going to result in catastrophic or fatal body burn. These catastrophic and fatal injuries can be prevented by wearing the appropriate PPE, including flame-resistant fabrics.
So a couple of points. So one, I'm showing you a video where somebody is not wearing, right? They're not wearing an FR. So they're wearing regular clothes, cotton and polyester, regular clothes, right? And so you're not wearing FR. That's one point. Secondly, as you saw, when the arc came out at you, it surrounded you, right? I mean, it was coming in front of you, but it surrounded the person. Even the back of the garment was on fire, right? The pants were on fire. And so you cannot control where the arc's going to go, right? It goes everywhere. It surrounds you, and then once your clothes are on fire. All right, so now next video I'm going to show you, which is what happens when you are wearing FR.
This mannequin is wearing Westex Ultra Soft jacket and pants, positioned in front of a disconnect with a Category 2 arc and no fire on the garment. There's also no break open, but you will clearly see that there's molten copper all down the front of the mannequin, including the pant legs all the way down to the cuffs and the ground. It's a significant amount of molten copper covering the mannequin from head to toe. At 3,000 frames a second, you get an outstanding look at the molten metal. There's a huge amount of it, and it comes out through the entire exposure, especially waist high right about now. And that waist high event continues. This molten copper was thrown in excess of 20 feet at significant enough volumes to cause garment ignition. And now we see the last of our arc fading, and the event at this point is molten metal.
Okay, so that kind of shows you, it's like a before and an after thing, right? If you're wearing it, what happens? If you're not wearing it, what happens, right? So let's talk about a few very fundamental questions, right? What is flame-resistant clothing? So clothing that is made from fabrics that self-extinguish, which means When you're exposed to a flame, they'll be on fire, but as the fire goes out, it self-extinguishes. It goes out. It is not on fire anymore, right? It is designed, very important, it is designed to limit, not eliminate injury, right? It's designed to limit, not eliminate injury. And then this, also very important point, the survival, the extent of injury, the recovery time, and the quality of life. After being exposed to that hazard, all depends upon how well did your PPE perform. How well did the garment that you're wearing, how well did it perform, will determine your survival, the extent of injury, your recovery time, as well as the quality of life. Another very simple question, why is FR needed? So the reason is that if you're not wearing FR, not wearing a flame-resistant fabric or garment, you're exposed to that arc flash. And as you saw in that video, the arc flash event was a fraction of a second event. It didn't even last a second, right? But what happened as a result of that is if you're not wearing something that is flame-resistant, those clothes are going to catch fire. And then the injury that you have is because the clothes are on fire. Not because of the arc flash event itself, but it's because your clothes were on fire. And so the burn injury that somebody gets because of those clothes being on fire. In fact, I would say that you're better off not wearing anything than wearing something that is non-F. Okay. Okay, so typically exposure energy is expressed in calories per centimeter square. Just as a basis for comparison, 1 to 2 calories will cause a second-degree burn. And typical non-FR workwear, and this is a very important metric to remember, typical non-FR workwear will ignite at 4 to 5 calories. Right? 4 to 5 calories is all it needs to ignite. All right, so I wanted to mention to you, I had already done this, I said that the objective is to minimize risk. You can never eliminate it. There is always going to be that risk. And we are not talking about primary protective clothing. This primary protective clothing is what you would wear to fight a fire. We're not talking about that. We're talking about secondary protective clothing. Secondary protective clothing is basically where you have intermittent exposure to whether it is molten substance, radiant heat, or flame. And it allows you a few seconds to escape that hazard. If somebody is exposed to that hazard and you're wearing an FR garment, it allows you that few extra minutes to get away from that hazard without major injury. Right? That's what we're talking about, secondary protection. Okay, so then as you're thinking about this, right, and you say, okay, what should be the key criteria you should be looking at when you decide, okay, should I have this PPE or that PPE, this garment or that garment, this fabric or that fabric, right? What should you be looking at? And I'm going to share with you what I believe. What I believe are the 5 most important criterias that you should be looking at when you think about whether you should wear one type of a garment versus another type of a garment, right? In the end, you have to come up with your own criteria, what you all think are the most important criteria. But I'll share with you what I think are the most important criteria. So first one is body burn, right? In the end, that's what we are trying to protect. Minimize your body burn. So the minimum body burn you get from one type of a garment versus the other is the first and the most important criteria. Second is durability and shrinkage. Now, I'm not talking about shrinkage like where you take your garment and you put it into a washing machine and then you put it into a dryer and it comes out short. I'm not talking about that type of a shrinkage. What I'm talking about is shrinkage when a garment is exposed to a hazard, is exposed to the flame. If it shrinks, when it's exposed to a flame, it's going to shrink onto a burned body. Right? It's not what you want. Then you have to peel it off. So very important criteria is that it should not shrink when it's exposed to a flame. Third criteria is softness and comfort. Now you say, okay, why softness and comfort? Why is that an important criteria? It's the third most important criteria. And the reason for that is, around the world, every single human being, when they are uncomfortable, the first thing that they do is roll up their sleeves. First thing, right? And as soon as you roll up your sleeves, you lost your protection. You got no protection anymore. That's why very important, especially in this part of the world, right? Where it's hot and humid, very, very important that your garment is comfortable to wear. Okay. Fourth criteria is a guarantee of performance. So here I have with me, and this is what is called a balaclava, right? It is made from an FR fabric, right? When you look at this, or even if you touch it, right? Can you tell that this is FR? Can you tell that this is fire resistant? There's no way, right? There is no way. It just feels like any other fabric or any other garment, right? So if you can't tell that this is flame resistant, you must have some kind of a guarantee that when you have that garment on a person, that person would be protected if exposed to a flame, right? And then the last criteria is a history of performance, right? So you must have, I can't just come here and say this fabric is the best fabric. Must have demonstrated it, must have shown, it must have been in a situation where it was exposed and it protected somebody. Right? So it must have a proven history. Those, in my opinion, are the most important criteria. I mean, there are several. In your specifications, you'll have various things in it. But in my opinion, those are the 5 most important criteria. Everything else is fundamental, right? These are the most important criteria. And this is, in my opinion, again, what distinguishes one product from the other. Okay. So this hazard that we're going to talk about now is arc flash. I called it hazard number 2 because you got flash fire and arc flash. This is arc flash is the second hazard. So what exactly is an arc flash? You saw the video, right? You saw the video of the arc flash, and you can clearly see that it's kind of like a fireball exploding, right? Rapid release of energy, temperatures going up to 20,000 degrees centigrade. Has a blinding light, right? Has a shock wave associated with it, a sound wave associated with it. Molten metal came at that person who was exposed to that hazard. Right? So that's what an arc flash event is. It's got all of these things. Now, what we are talking about here is a fabric will protect you against the thermal hazard, right? Protect you against the temperature, protect you against the flame, protect you against the molten metal when it comes on your fabric. But for your shock wave or your sound wave protection, you have to have other PPE, right? You got to have ear protection, and you've got to have the right shoes and stuff like that. Okay. Now, what causes an arc flash? Of course, you all know this. Any fault in an electrical equipment, right? Whether it's switch gear, any fault in the electrical equipment because of a drop tool or because of dust buildup can cause a fault, and that's what causes an arc flash. The thing though is that the intensity of that arc flash is so high that if the clothes if you're not wearing an FR garment and the clothes catch on fire, stop, drop, and roll is not going to extinguish it, right? It becomes catastrophic. All right, so let me share with you some statistics. Burns can happen as far away as 10 feet from the equipment that you're working on, right? So it's very important to have an approach distance, right? In terms of how intense that arc flash could be from that equipment, you have to have an approach distance. So even people who are just happen to be walking by, if they are within that approach distance, and I'll tell you how to calculate the approach distance, they can be exposed to that hazard. So I've got these statistics. This was a couple of years back. This is statistics from the US. There were 30,000 arcs in 2014 in the US. 7,000, in spite of all of the awareness, right? All of the awareness that was there, yet 30,000 arcs happened in the US. 7,000 burn injuries happened that year. 2,000 people were admitted to a burn center, and not all walked out the front door, right? So why is it? You know, there was so much awareness. Why is it? Primary reason is that they were not wearing it properly. You know, they had their shirts folded up, you know, or they hadn't repaired it when they should have been repaired. It was too dirty, whatever it is. It's not properly using the garment. Okay, so you know, there is regulation, there is government regulation that that governs exactly what you can sell into this market. 70E, NFPA 70E is the regulation that says this is what governs what you can sell as an FR fabric or an FR garment. And basically, let me, you know, no need to read through all of that. I'll just give you a summary on that. 70E came about when there was recognition that that you can calculate the intensity of the electrical equipment that you're working on, right? You can calculate it. If you can calculate the intensity, and then all you need to do is get a fabric that has the insulative capacity equal to or higher than the intensity. And if you do that, you can protect a person, right? You have an insulative capacity of a garment or a fabric higher than the intensity of the energy or intensity of the equipment that you're working on, you will be able to protect that person. That's all it is. That's all it comes from. So this incident energy, I was talking about the incident energy of the equipment, or the intensity of the arc flash, it can be calculated. So I'll show you actually, let me show you the variables. There are several variables that determine the incident energy, the intensity of the incident energy for an arc flash. But primarily there are three factors, right? You've got your amperage, your cycle time, and your distance away from the arc. Those are the three things primarily that govern the intensity of your incident energy. Okay? Now, amperage and cycle time are always published on the equipment itself. And every electrical equipment will have an amperage and a cycle time already on it. Right? Distance from the arc. This is the distance away from the equipment. So if you're working on an equipment, how far away are you from that equipment? That's what the distance is, right? So distance is something you have to estimate. When you're calculating incident energy, you have to estimate what the distance is. And this is where you have to be conservative when you estimate what that distance is, right? Because if you are using torque on an equipment, you're not going to be standing away, too far away, right? You're not going to be 2 feet away. You're going to be very close to the equipment. And so when you use that distance, be very conservative. Okay, so then there is a mathematical formula. In fact, once you have the amperage and your cycle time, and you have estimated a distance, you can actually plug it into that mathematical formula, and it will calculate the incident energy of the equipment that you are working on. Once you get the incident energy of the equipment you are working on, then all you need to do is find a fabric or a garment that has the insulative capacity equal to or higher than that incident energy. Once you do that, you are protected. You're in front of it and you're protected. Okay? Now, you can use this mathematical formula, or you can go to 70E, and 70E has a table, right? And all you have to do is you have to look at, and it's a table that goes over 4 or 5 pages. So you can actually go ahead and look at what type of work am I doing, and based on the type of work that you're doing, it'll tell you what category of fabric or garment you need to protect you, right? And it also gives you an approach distance. So you have to create a boundary. So it gives you both the important things, right? Once you go through the table and you say, okay, maybe I'm doing this activity right here, right? So you say, go here and say, I need a category 4 garment, category 4 fabric, and then I need to have an approach distance of 12 meters, right? So you get your approach distance there, and you make sure that you're wearing a category 4 garment. So what exactly is a category 4 garment? Okay, so I was saying, okay, so what exactly is a category 4 or a category 2 fabric, right? What exactly is that? Again, this is published in the NFPA 70E, it's a table, and it basically talks about the ATPV rating. So it's expressed in cals, right? So it's the energy. So if your incident energy of your equipment is 4 cal per centimeter square, you need a Cat 1 fabric or a Cat 1 garment, right? If it's 8, you need a Cat 2. Okay, so let me ask you this. Let's say if you have an incident energy of 10, what category fabric would you need? 3, that's correct. It always goes up, right? If it's above that incident energy, you must go up. Okay, so, and that's where category 4 comes from. It comes from 40 cal, right? So if you have a 40 cal in, which a lot of switching gears kind of have 40 cal, then you would need a Cat 4 type of. Couple of other points I want to make on this slide. When it up to, okay, so if you remember, I had a slide where I talked about the fabric or the garment will ignite if it's exposed to 5 to 8 calories per centimeter square energy. You remember in a couple of slides back I talked about a fabric will ignite at 5 to 8 calories per centimeter square. So as you look at this table, right, 5 is going to be a Cat 2, right? So typically, and around the world, most of my experience has been people tend to wear Cat 2 as a daily wear, right? So when you're wearing your daily uniform, that's what you wear, a Cat 2. Beyond the Cat 2, the equipment starts to become heavy, right? The garment starts to become heavy. And so then what people do is that they keep that Cat 3 or a Cat 4 garment alongside that equipment. And so you're wearing your daily wear, but when you're working on a 40 cal per centimeter square incident energy equipment, then you put on the Cat 4 garment. So the difference is it becomes a task-based. So you wear it only to perform that task, right? And up to Cat 1 and Cat 2, you can wear it as a daily wear. All right. Then there are certain other things I think that are important to, the things that you have to watch out for. I'm sure you already have these things in place. I saw the safety video before I came in. You have to make sure when you're working on an electrical equipment, you don't have anything metal in there and things of that sort. So these are, again, based on 70E, just do's and don'ts when you wearing. So not just your garment that you're wearing, but you must also make sure that you don't have.
If I may, real quick, there's this one line here about cloth with conductive thread. We do run into that on a fairly regular basis, body shop, when we bring on the Kevlar sleeves. I don't know if you use those or not. Recommendation from you, I'll ask, what goes on the outside, what's on the inside? Do we have the AR on the outside and Kevlar sleeves underneath, or the other way around? Whatever your clothing is. Yeah.
The Kevlar sleeves are for what?
They're to protect from being cut.
Okay. No, so the outer garment must always be the FR garment. You cannot wear anything on top of the FR garment, right?
Yeah, and that matches my understanding as well. Now, what we've done at a number of sites, because it's really unusual to need both at the same time. You're either working in a body shop where you require the sleeves, or you're doing the electrical work. And so what most of our plants do is you just wear your AR clothing and you take the sleeves off when you're performing the electrical task. It needs to be part of your documented plan, documented program, because other people in the body shop are going to walk by. They're going to see you without your sleeves, and they're going to go, hey, wait a minute, that guy's in violation, and all that. So it's just to clarify that if you have to wear them both, you wear the Kevlar underneath, which means you probably got to take your coveralls off, put your sleeves on, put it back on again, or if you're doing the work, you can't have the conductive threads. You need to take the sleeves off, set them down, do your electrical job.
Okay. Then I want to make one other comment about the standard, right? So not so much 70E, but NFPA 2112, which is also a flash fire hazard, essentially the same thing for flame resistance. It sets failure at greater than 50% body burn. What that means is that if when you're wearing that particular garment or fabric, and you're exposed to a hazard, if you get more than 50% body burn when you're wearing an FR fabric, then you cannot sell that fabric or garment commercially into this application. More than 50%. So basically it's saying is, the regulation is saying that your fabric or your garment, when you're wearing it and you're exposed to a hazard, must have a body burn less than 50%. If it's less than 50%, you can commercially sell it. But think about that for just a minute. 50% and you can sell it. 50% of your body is burned and you can commercially sell it. In my opinion, it's a very lax standard, right? 50% of your body means the front of your body is completely burned. And you can sell it commercially. Very lax standard, right? But this is why I had earlier mentioned a key criteria being body burn. So there will be several different types of products that you can buy, right? Products that you can get. The one that you should choose, my opinion again, is the one that has the minimum body burn, least amount of body burn. Okay, so this is the flash fire hazard. I'm going to skip through the flash fires and go into. So if you remember, the fourth criteria I had was a guarantee of performance, right? You must have some kind of a guarantee of performance, because when you look at the FR fabric or FR garment, you cannot tell that this is flame resistant, right? And you certainly cannot tell I give it to you today, and I say, this is FR. You wear it. You say, okay, it's FR. It's going to protect me when I'm working on an equipment, right? But how do you know a week from now it's still FR? How do you know it's flame resistance a week from now, a month from now, 6 months from now? You're still wearing it. How do you know it is flame resistant, right? So now, obviously in these kind of cases, the government comes in and says, okay, here's the regulation, right? So NFPA 2112 says, remember I talked about the 50% body burn, but it also says that your garment has to be washed 100 times, right? And then pass the 50% body burn. Right? So 50% body burn, again, it's too much body burn, but that's what the regulation says. You must wash it 100 times, and it must still pass the 50% criteria. All right, so we looked at this, and we said, look, this is a very, very important thing, because when people wear the garment, and they're wearing it, like I said, 6 months from now, year from now, they must feel that they are protected. They must be protected, right? So we decided that as a company, we will not sell anything that passes 50 washes or 100 washes or 150 washes, right? We basically said everything that we will sell is lifetime guaranteed. What that means is that as long as you are wearing it, you would have FR. Right? In other words, your garment might fall apart, but the FR will not go away. That's the guarantee. You had a question?
Indeed, I have 2 questions.
That's a good segue into my next slide, because so there is the way we do our FR, the way we make our FR fabrics is that we make sure that, and this is just an illustration, that we make sure that there is FR, a long chain FR polymer in every single fiber, right? We put it in every single fiber. So as long as the long chain FR polymer is in every single fiber, it will give you lifetime protection. That's how we get lifetime protection. It is not a topical treatment. Right? What you will get, though, I mean, you will get, there are fabric suppliers that do a topical treatment, and then we, in fact, picked up a bunch of fabrics from different sources, from our some customers around the world, and we went ahead and did the NFPA 211 NFPA test on it, and what you find is a variation. There are fabrics that will not last 5 washes. You do 5 washes and their FR has gone away. And the result, and the reason for that is because that is a topical treatment. So they take one particular set of fabric, they go ahead and send it for the NFPA test, they pass that test, and then they sell yards and yards, meters and meters of fabric. But when you actually do the test, you find that after 5 washes, sometimes 10 washes, 15 washes, the FR has gone away, right? And that is all because it is a topical treatment. That is why we don't do the topical treatment. That's why we do this. We put it into the fiber. This is an example of a topical treatment. Once you do a topical treatment, it is prone to hydrolysis. But just sitting on the shelf, it is prone to hydrolysis. And once it's in a humid environment, the FR goes away. Okay. All right. So then a lot of questions were around this, right? Around this slide, which is proper use. How do you properly use your FR garment? So first point, it must always be appropriate to the hazard. And what I mean by that is, if you're working on an equipment that has an incident energy of 30 cal then you must use a Cat 4 fabric or a Cat 4 garment, right? So it must be appropriate to, so arc rated, it must be appropriate to that hazard. That's the first point. We talked about this a little bit earlier, right? It must always be the outermost layer, right? Because you don't want anything that is outside of your FR to catch fire, because then you've defeated the purpose. It's the outermost layer that extinguishes, and therefore nothing else gets ignited, right? So must always be the outermost layer. Must be worn correctly, right? Must be zipped, buttoned, must be worn correctly. That's why comfort is important. You can't roll up your sleeves, right? Inner garments, what do you wear as inside, right? So it should always be natural, non-melting. You know, a lot of times these days, especially young people will wear sports shirts inside, right? And if that melts, it'll melt onto a burned body, right? Or so always wear something that is natural, non-melting. And then these two things we talked about, right, at length. Clean, must always be clean, right? Now this, of course, applies especially to people who are in like an oil and gas industry, because they work with a lot of sludge and all that kind of stuff. So must be always clean, must be repaired correctly, and removed from service if it cannot be repaired correctly. So those are just good things to remember as you. All right, so with that, I'm going to now come to the most important criteria that, at least in my view, the most important criteria, which is body burn. And I'm going to show you, Milliken makes all the technologies, right? We make every single technology except for the topical treatment. We make every single technology that is used in the market, right? So I'm actually going to show you the performance of those technologies in this criteria, body burn, for body burn criteria. All right, so before I do that, the body burn criteria is an ASTM test method, right? F1930 test method. It is basically a mannequin, and you put a coverall on the mannequin, and then you expose it for 3 seconds to a flash fire, right? And then you measure body burn, and it must have less than 50% body burn to then pass, right? And if it passes, then you can sell it. Now there are about 200 thermocouples on the mannequin that actually measure your body burn, right? The only thing that is not covered on the mannequin is the neck and the head, which accounts for about 7% body burn. So whatever body burn number that you get from this test, you subtract 7% from that, and that's your body burn data, right? Okay. So the first video I'm going to show you is this fabric is called Ultra Soft, right?
This mannequin is wearing a Westex Ultra Soft 7-ounce coverall. If the torches come on, the duration is 3 seconds, and when the torches go out, the fire goes out. There's a very brief after flame limited to the left elbow that we'll get a better look at in slow motion. The flash fire come in, and when the torches go out, there's a very brief and very small piece of after flame limited to the left elbow of the garment. It lasts well less than 1 second. As we take a closer look, we see no shrinkage radially or vertically on this garment, on the arms, legs, or torso, and there doesn't appear to be any dye sublimation or carbonization either, although upon closer inspection we may find some slight carbonization. And as you can see, when the coverall is removed, the t-shirt is substantially less carbonized than many of the other products we've looked at, which also suggests better insulation of the coverall and lower body burn injury. At the University of Alberta, the body burn data on this fabric averages 14%.
That's the Ultra Soft. The second one here is a Nomex.
This garment is a 6-ounce Nomex 3A coverall in a 3-second flash fire 2112. Torches are lit, you have a 3-second flash, the torches go out, and there's some after flame on the garment, but the good news is it does self-extinguish. This garment is flame resistant and will save your life by not continuing to burn after the initial exposure is over. Now, there was some after flame and there was some significant garment degradation, and we can take a closer look at that. The garment is going to be shrunk both vertically and radially, and if you take a close look at the leg and the cuff area, you're going to see both of those phenomenon. You have some dye sublimation where the garment is pink instead of blue, complete dye sublimation where the garment is khaki instead of pink, and carbonization where the garment is orange peeled or even more dark than khaki. If you look at this and you suppose that the afterflame and or the garment degradation might have contributed to burn injury, you're right. The body burn data for this garment averages 34% second and third degree burn. The majority of that body burn occurs in areas not covered by the underwear, the arms and the legs, because there's only one layer, and that one layer, while it does not burn, support combustion in air, also does not insulate adequately to this hazard. So we can clearly see the value of the second layer when we remove the coverall and see that the t-shirt is badly degraded. Enough thermal energy has gotten through the single layer portions of the coverall to char the underwear as well. And the coverall has to be cut off of the mannequin because of the shrinkage that occurs, makes it difficult or impossible to remove normally. So the University of Alberta people cut some or all of the back to be able to remove the garment. And there you can clearly see where there were 2 layers in the pocket area, where there were 2 layers in the placket and zipper area, the t-shirt is undamaged. Where there was 1 layer of the FR coverall, you have an excellent illustration of the fact that while it doesn't burn, it also doesn't insulate adequately for that hazard. Here's a body burn silhouette for the Nomex 3A 6-ounce coverall, and as you can see, the average is right around 30%.
Okay, so a couple of points I want to make on this slide. So as you look at the test that is done, right? If you have a placket, right? If you have a placket or a pocket, what you see is you don't see when he takes the coverall off, you don't see any heat going through the overall coverall. You know, when you see the brown or the orange thing on the inside T-shirt, that means that the outer fabric did not insulate well enough, so the heat went through, right? And that's why you got that orange or brown on the T-shirt, right? And what you notice is that wherever you have 3 layers, so if you had the placket or a pocket, you don't see that, right? And when you don't, you actually see that, right? In this slide, you saw that. So when your body burn goes up to 30%, 40%, you start to see more of the heat going through the fabric, through the outer fabric and into the inner layer, right? So which basically means that your outer layer is not insulative enough, right? You could use something that is better insulation. Sorry, could use something that is better insulation. Okay, so does that make sense? Yeah, sure. Okay, so there is. We don't use this one. I can show it to you, or we can. Okay, let me just go ahead and show it to you anyway.
This coverall is made of a fabric called Proterra, which is a blend of monocrylic fiber, 65%, along with Nomex and Kevlar. This flash, like the others, will last 3 seconds, and we'll be looking for afterflame, if any, garment degradation, things like that. We have a 3-second flash fire, and then a small amount of afterflame and a massive amount of smoke. And the garment continues to smoke for considerably longer than some of the other products we've looked at. It shows significant evidence of carbonization over most of the body. On the close-up of the leg area, you can see, again, some shrinkage and significant carbonization of this product. Proterra shot, slow motion. If you watch carefully when the torches turn off, there is very brief afterflame. It does self-extinguish almost immediately. While it's very brief, it's body-wide pretty much. and then there's a massive amount of smoke that is put out initially and continues to be put out down at both the leg area, the torso, as well as the arms. As with some of the other products we've looked at, this particular pair of coveralls needs to have a scissors taken to the back because of the shrinkage, so they're going to cut a significant portion of the back of the garment open to allow it to be removed from the mannequin. We take a closer look at the undergarments from under this, and you notice significant charring and degradation of the cotton t-shirt as well, because while this product did not ignite and continue to burn, was flame resistant and saved the wearer's life, it again did not insulate overly well as a single layer to the hazard. Here's the body burn silhouette for the Proterra 6.5 ounce coverall, and the body burn is 30.95%.
Okay. The next thing is, so I wanted to talk about the, I mentioned comfort earlier, right? About not rolling up your sleeves and things of that sort. So here's an actual test that was done. A synthetic product, which is Nomex versus Ultrasoft, which is cotton, and you can see the result of this test that a 6-ounce synthetic material has this comfort of a 10-ounce cotton-based material, right? So it's natural. I mean, cotton-based material would be more comfortable. That's what it shows. All right, now there was a question about certifications, so I'm just showing you some of the certifications. It comes like that. This is for the mannequin test. So it's the ASTM test. That's showing you the Nomex CXP. And that's showing you the Ultrasoft. So here's the University of Alberta, and you will get the body burn test. All right. Okay. So these are some of the companies that are using our product, and some use Ultrasoft, some use the Nomex CXP. It's their choice what they want to use. I think you've probably seen the product that is available from Salisbury. Salisbury as a company was a company, now it's acquired by Honeywell. They use Ultrasoft, the cotton-based product. That's the one they use. Then you've got Shell around the world, various locations, they all use Ultrasoft. And then you have a whole bunch of drilling companies that use these products, and most of the drilling companies use Ultrasoft again because of the weather, because of comfort. And so does P&G. P&G has a global specification, and it's on Ultrasoft. So they don't even use any other technology, they only use this. Okay, so just to summarize here, what you've seen so far is, how do you measure body burn? How can you differentiate one fabric, one garment versus the other? We talked about durability and shrinkage control, how important it is that it not shrink when it's exposed to a hazard. We talked about softness and comfort. We talked about guarantee, right? That it must be FR for life of the garment. The only thing that I have not mentioned here, I have not talked about so far, is the proof. Okay, so I've said that we have been in business for a long time, but that's not proof, right? So I'll show you one proof. This is an incident. So we captured a video. We didn't capture it. It's actually an incident that happened in Brazil. So what you will see in this video is that there are two people who are working on an electrical equipment. There is a third person who's sitting in a car and monitoring those two people as they are required to, right? And he has a video on, so he had that video on, and so that's the reason we were able to capture the video. Now the person who's monitoring is sitting in the car and he's got his radio on, so you'll hear some music. but you'll see the real incident. Couple of comments I'll make on that one. One is they were wearing the right PPE, right? They had a face shield on, they had the right garments on, they had the right shoes on. They had an approach distance that they had marked, right, based on the equipment, the incident energy of the equipment, and how far the arc flash could go. So everything they had done properly, right? And they were wearing this is an ultra soft that they were wearing, and as you could see, they just brushed themselves off, and they were both okay, no issues there. Okay, then this slide is an example of. Oh, sorry.
Sorry for interruption.
Sure.
All videos which you show up dedicate the influence of heat or over temperature. But what about the sharpness components? It can protect.
Okay, so as long as it's molten copper or something coming out of the equipment, it does a fairly good job of protecting it. Now, something very sharp that comes out, it is not meant for that. So it is basically meant for thermal protection, and then it protects against copper debris that comes at a person. But if there is something really sharp, metal or something that flies out of there, it's not meant for that protection for that. This is an example of just a specification. I mean, I'm sure you will have specifications, but it's an example of specification where essentially I'm showing that specification should be performance-based, right? So this is just an example. I mean, you probably have your own. What I wanted to do is show you one, since there were a lot of questions on where do you get your garment tested and stuff like that, right? So I wanted to show you an example. This is a company based, it's called Tenaga National. It's based right here in Malaysia. It's the largest utility in Malaysia. It provides all of the power generation, distribution, transmission in Malaysia. 80% of Malaysia's power is supplied by this company, Tenaga National. Now, Tenaga National had some accidents that happened in their plant, and the reason why those accidents happened was because the FR product that they were wearing was not very insulative, right? So what happened was they were exposed to a hazard, and their arm got burned. The reason their arm got burned was because what they were wearing was something that had a half sleeves, right? So it protected up the rest of the body, wherever they had the inner garment, but this part was a single layer. And the hand got burned, and from the hand, the infection got in from there, and there was one fatality out of the 3. So they came to us, and they said, we want a specific product. They wanted to have protection up to 40 cal, right? But they also use these oil-based transformers. So they said, give us also protection. Not only should it protect an arc rating of 40, but it should also protect in case there is an oil splash, that it should protect against that as well, right? And it catches fire, it should protect against that as well. And so we made that garment for them. We made the, designed the fabric, made the garment for them. And that was not enough. They actually went to Kinetrix, which is the lab in Toronto. And this is where they did the test. And when they did the test, they did it for, so we had it rating for 45 cal, even though their equipment was 40. But they tested it for 46 cal, and then they tested it for 51. And what he's holding up here and showing that it did not break open, right? So you can have your independent test done at these labs. They'll do it for you. Okay, so let me just take 2 slides to talk about just to give you an introduction to the company. Some of you may not know the company. This is a 150-year-old company, and this is the 150th year of the company. It's still privately held. We manufacture about 30,000 products. Our operations are textiles and chemicals. About 7,000 associates work for the company, so it's not as big as GM. And we have about 39 plants in five different countries. There are certain things that we are very proud of, and I'd like to share them with you. This is the last slide. There is an institute called Ethisphere, which ranks world's most ethical companies. We've been ranked in that since 2007, and every year since then, 2016 as well, we got that ranking. We are carbon negative, believe it or not, in spite of the fact that we have a chemicals operation, still carbon negative. All 39 manufacturing sites of the company are designated VPP star sites. That designation is given by OSHA, and it's given, it basically says that your processes are robust enough that OSHA does not need to come and inspect us, so they don't inspect any of our manufacturing sites. Then occupational health and safety has recognized Milliken twice as one of the safest companies in the world. And then on innovation, we have over 5,000 patents, about 100 PhDs work for the company, and various quality awards. The Malcolm Baldrige Award was the US award, and then in Japan, European quality awards we won over the years. So just thank you for letting me share that. That's something that we are proud of. I'm done. Any other questions, I'll be glad to take.